Good morning, students. Today we are going to learn the preparation of dinitrogens and the properties of the dinitrogen and the uses of the dinitrogens. Okay. So first I will start from the what are the uses of the dinitrogen in daily wages or daily. Okay. So the dinitrogen first is useful to the manufacturing of the ammonia and calcium cyanide. Okay, ammonia and calcium cyanide. So the dinitrogen can also useful to produce inert atmosphere. Inert atmosphere means options of the oxygens. Okay, in industry or chemical reactions, this oxygen will spoil the so many metal atoms and catalysts. That's why we have to maintain the inert atmosphere to carry out the chemical reactions. Okay, in that cases we will pass the nitrogen gases, then that atmosphere is called inert atmosphere. So nitrogen will replace the oxygen. Okay, that is called inert atmosphere. The liquid nitrogen is used as a refrigerant to preserve the food items and biological materials. Okay, liquid nitrogen also useful to preserve the biological materials. Biological materials also spoil due to the presence of oxygens. That's why in the presence of inert atmosphere, the lifetime of the biological materials will be remain for longer time, as well as the food items. Food item also will spoil due to the presence of oxygen. That's why the chips items, and whatever the packing items, generally they will pass through the dinitrogen gases and they will pack that one, so then that will be remain for the longer times. Okay, so these are the uses of the dinitrogen compound. First is it is useful in the manufacturing of the ammonia and calcium cyanide, and it is also useful to produce inert atmosphere, and the liquid dinitrogen useful to used as a refrigerant to preserve the biological material and food items. So next one, the preparation method of the dinitrogen. Preparation method of the dinitrogens. Okay, so dinitrogen generally can be prepared the two methods. Okay, two methods. First method is that is a commercial method. Method one is a commercial method. So the dinitrogen commercially can be prepared. Commercial means large scale, ton scale, quintal scale we can prepare. Okay, the dinitrogen can be prepared commercially by liquefaction and fractional distillation of air. Okay, so what is this one? Liquefaction and fractional distillation of air. Okay, that means yesterday in the last class we studied the dinitrogen is compresses in the earth atmosphere by 78% by volume and 75% by the mass. So that means in the atmosphere itself the dinitrogen is available. Along with the dinitrogen, oxygen is also available. Okay, oxygen is also available. That's why we are collecting the air from the earth atmosphere and we are converting them into liquids. That is called liquefaction. Okay, that means gases are converting into liquid. That is called liquefaction. When we are collected to as a liquids, they are doing the fractional distillation. Fractional distillation. Okay, in the fractional distillation, the liquid which is having lower boiling point will come out first. The liquid which is having the higher boiling point will remain in the container. Okay, as we said, we have collected the two gases from the atmosphere, that is the liquid nitrogen and oxygen. Liquid oxygens are there in the liquid state. When we are doing the fractional distillation, the liquid nitrogen which is having low boiling point, that is 77.2 K, will come out first, and the liquid oxygen which is having high boiling point, that is 90 K kelvins, will remain in the container. Like that one, the commercially the dinitrogen is preparing from liquefaction and fractional distillation of the air. Okay, this is the method one. The second method is the laboratory method. How we are preparing in the laboratory. First method in the laboratory preparation. First, the heating or the treating of the aqueous ammonium chloride in the presence of sodium nitrate will give the nitrogen gas. Okay, so what we are doing, we are taking the ammonium chloride in the round bottom flask, and to that one sodium nitrate we are adding. Then by the chemical reactions between the ammonium chloride and sodium nitrate will generate the nitrogen gas along with water and sodium chloride. Okay, it is the first method, the laboratory method, that is by treating of ammonium chloride to the sodium nitrate will give the nitrogen and water and sodium chloride solution. Okay, and second method is heating of or thermal decomposition of, heating or thermal decomposition of ammonium dichromate. Ammonium dichromate will give the dinitrogen gas, and water as well as the chromate. This is the K2Cr2O7, potassium dichromate. Similar to that one, here ammonium is there. That's why it is the ammonium dichromate. Thermal decomposition. That's why we say that one, thermal decomposition of ammonium dichromate will give the dinitrogen and water and the chromate. These are the laboratory methods where we can prepare the dinitrogen. So to prepare pure dinitrogen, because in this one, small side products are forming, so which are contained with the nitrogen gases. To prepare directly pure methods of the dinitrogen, we can heating up the barium azide or sodium azide, we can prepare the pure the dinitrogen gases. Only barium and sodium will be remaining in the container. The remaining gases will be come outed with the pure form. So that means to prepare the pure form of the dinitrogen, just heating of barium azide and sodium azide, we will get the pure of the dinitrogen compound. These are the methods to the preparation of the dinitrogen compound. First one is the commercial method. We are prepared the dinitrogen by the liquefaction and fractional distillation of the air. Second method is the laboratory method. In that one, we prepared by treating of ammonium chloride with sodium nitrate. Second method is the thermal decomposition of ammonium dichromate. And third method, fourth method, to prepare where pure form of the dinitrogen, just heating of the barium azide or sodium azide will give the dinitrogen compound in the pure form. These are the preparation methods of the nitrogen compounds. Properties of dinitrogens. Dinitrogen is a colorless, odorless, tasteless, non-toxic gas. This is the dinitrogen is a colorless, odorless, tasteless, and non-toxic gas. This dinitrogen is lighter than the air. Dinitrogen is lighter than air. In the last class we studied the boiling point of the dinitrogen is 77 Kelvin, and oxygen boiling point is that is 90 K. That's why dinitrogen is lighter than air, and it is slightly soluble in water at 273 K. It is slightly soluble in water at 273 K. Dinitrogen is inert at room temperatures. Dinitrogen is inert at room temperatures due to high bond enthalpy. We know that one. Between the two nitrogen, triple bond is there. So to break this triple bond, high energy is required. That's why dinitrogen is inert at room temperature, because that much of energy is not available at room temperature to break this triple bond. That's why dinitrogen is inert at room temperature due to high bond enthalpy. And the reactivity of the dinitrogen increases. The However, this is the inert at room temperature, but the reactivity of the dinitrogen increases as the temperature increases. At high temperature, it will react to the metal compounds like lithium will give the lithium azide, magnesium it will give the magnesium azide. Yesterday we also discussed the point whenever the 15th group elements react to the metal compound, they will exhibit -3 oxidation state. That's why in this case lithium azide, the oxidation state of the nitrogen is -3, magnesium azide, oxidation state of the nitrogen is also a -3. That means at high temperature, the dinitrogen will react with the metals like lithium and magnesium will give corresponding metal azides. The dinitrogen can also react with the hydrogen gas. In the presence of iron catalyst will give the ammonia. It is an exothermic process. Okay. Again, this preparation, the same method we are going to be learned in the preparation of ammonia. This method is known as Haber process. That means the dinitrogen also react with the hydrogen gas in the presence of iron catalyst will give the ammonia. The dinitrogen can also react with the oxygen. At high temperature, that is at 2000 K. It will give the nitric oxide. It will give the nitric oxide. It will give the NO. It will give the nitric oxide. Now, this is the properties of the dinitrogens. So first very simple one. So it's a colorless, odorless, tasteless, non-toxic gas, and it's lighter than the air, and it is slightly soluble in water at 273 K, and dinitrogen is inert at room temperature due to high bond enthalpy. That is the nitrogen is having 3 double bond between the nitrogens. And however, the reactivity of the dinitrogen will increases as temperature increases. At high temperature, it will react to the metal compounds like lithium and magnesium will give the metal azide. In the metal azide, the oxidation state of the nitrogen is -3 oxidation state. The nitrogen also react with the hydrogen gas in the presence of iron catalyst will give the ammonia, and also react with the oxygen at the high temperature will give the nitric oxide. These are the properties of the dinitrogens.